So you've got a calculus exam in a matter of hours, and you might have forgotten a few formulas over the course of the semester. Not to worry, my friend. Not to worry. Let's start with trig. For a 30, 60, 90 triangle, its sides are 1, 2, and square root of 3. 45, 45, 90s have sides of 1, 1, and square root of 2. This is useful when figuring out stuff on the unit circle, where the cosine is like the x value, and the sine is like the y value, and the tangent is the y value of the point where the angle crosses the line at x equals 1. And since the radius of the unit circle is 1, sine squared plus cosine squared equals 1. Oh, and here are some identities which may come in handy. And you can't forget about double angle formulas. Cosine, make up your mind! The derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of tangent is secant squared. The derivative of arcsine is 1 over square root of 1 minus x squared. Arccosine derived is the same but negative, and arctangent derives to 1 over 1 plus x squared. And last but not least, hyperbolics. Cosh is e to the x plus e to the negative x over 2, and sinh is the same but with a minus instead. Cosh derives to sinh, and sinh derives to cosh, almost like normal sine and cosine, and cosh squared plus sinh squared is still 1. Still there? Good, because we still have a lot to cover. We'll start with some logarithm rules. First off, log base a of c equals b means a to the power of b equals c. Log with no base is assumed to be base 10, and ln, or natural log, is log base e. Log of x times y is the same as log x plus log y, while log of x over y is log x minus log y, and when there's a power involved, you can just move it to the front to simplify things. A little more about e. The derivative of natural log is 1 over x, but x has to always be more than 0. And e to the x stays e to the x when derived, with little change. Onward to limits and all their glory. Remember that if a limit approaches 0 from the positive side, it's as if you're substituting a very, very small number. And if it approaches 0 from the negative side, it's like a very, very small negative number. And things get a little weird when the unit circle is involved. Side note, limit of sine x over x as x approaches 0 is 1. Just know it. With infinite limits, 1 over infinity is 0. 1 over 0 from the positive side is infinity, and from the negative side is negative infinity. Also, infinity is not a number. Do not make these mistakes. Just don't do it. You're doing great so far. All you have left are conic sections. Parabolas first. Standard form is x squared equals 4py, or vice versa. When it shifts, you throw in some extra variables, h and k. The vertex is hk, the focus is hk plus p, and the directrix is y equals k minus p. Next, ellipses. X squared over a squared plus y squared over b squared. Whichever is bigger, a or b, determines the shape of the ellipse. The foci are at point C, which makes a nice right triangle with a and b. Flip an ellipse inside out and get everyone's favorite, the hyperbola. The formula is the same as an ellipse, but minus, and a is always under the positive variable, regardless of size. The foci are still at C, but C is the hypotenuse this time. And the asymptotes are y equals a over b, usually. So that about sums it up. Trig and its derivatives, logs, limits, and conics. Just make sure you don't treat infinity like a number, remember the Pythagorean theorem, and don't let hyperbola scare you too much, and you'll be fine. Good luck and Godspeed.